Welcome to Dreams of Gravity. If this is your first time here, settle in gently. Take a moment to find a comfortable position, perhaps lying down in bed or wherever you feel most at ease. Let your body relax, your breath slow and steady, like the gentle rise and fall of waves on a quiet shore. Close your eyes if you'd like, and allow yourself to drift into this serene journey through the cosmos. Tonight, we'll explore the vast wonders of the universe in a soft, unhurried way, letting the stories of stars and shadows lull you toward peaceful sleep. Imagine the universe as an endless ocean where galaxies drift like vast schools of luminous fish, each one a swirling collection of stars, planets, and whispers of ancient light. In this cosmic sea, not everything is calm. Sometimes these grand gatherings of matter encounter something profound and mysterious, a supermassive black hole. These are not monsters of destruction in the way stories might paint them, but rather quiet architects of change, pulling and shaping the fabric of space with a gravity as patient as the tide. This gravity, born from the curvature of space-time itself, holds the galaxy's form like an unseen hand cradling a fragile bloom, ensuring that even in motion there's a profound sense of underlying order, a rhythm that echoes the steady cadence of your own breathing as you listen now. It invites a contemplation of balance, where forces that draw close also allow for expansion, much like the way lungs fill and empty in harmonious measure, sustaining the quiet vitality of existence. In this delicate equilibrium, the universe reveals its preference for stability, where perturbations like an approaching black hole serve not to shatter, but to refine, much as a gentle current polishes pebbles along a riverbed, smoothing edges into graceful forms over unhurried ages. This refinement, observed in the subtle alignments of galactic arms, suggests a cosmos that favors elegance, where chaos yields to patterns as enduring as the slow orbit of a moon around its world, whispering of a deeper harmony beneath the surface play of forces. Such harmony, evident in the way spiral densities wave through the disk, arises from self-gravitating instabilities that foster the arm's persistence, a resonant dance where stars and gas align in collective motion, much like a choir finding its pitch in the hush before song. Our story begins far beyond the familiar glow of our own Milky Way, in a distant corner of the universe where a galaxy much like ours is on a slow, inevitable path toward collision. Picture it, a spiral of billions of stars, arms curving gracefully like the petals of a cosmic flower, stretching across 100,000 light-years. This galaxy, let's call it Ilara for the sake of our gentle tale, has been journeying through the void for billions of years, its stars born from clouds of gas that once floated like morning mist. These clouds, vast and diffuse, gather slowly under their own weight, much like how fog in a valley condenses into droplets on a cool evening, forming the first hints of structure in what was once empty expanse. Over eons, this process repeats, layer upon layer, building the intricate patterns we see in telescopes today. Patterns that speak of a universe not born in haste, but in a deliberate, whispering unfoldment. Within Ilara, these patterns hold stories of quiet endurance, where pockets of interstellar medium, sparse gas and dust, sustain a delicate balance, occasionally disturbed by passing stellar winds that ripple through like a soft breeze across a sleeping lake, preparing the stage for the deeper changes to come. These winds, carrying charged particles from stellar surfaces, ionize the gas they touch, creating faint glows that trace the galaxy's skeleton, much like the subtle luminescence of plankton in ocean depths, revealing hidden flows in the quiet night. Such glows, captured in infrared observations, hint at the molecular complexity within, where hydrogen molecules form the scaffolding for future stars, a foundational chemistry as simple and profound as the first bonds in a growing crystal. These molecules, colliding at low speeds in the cold, release photons that warm the surrounding dust, a gentle heating that mimics the soft glow of embers in a hearth, nurturing the conditions for denser clumps to emerge without rush or fanfare. In this nurturing, the dust grains act as catalysts, their surfaces absorbing atoms to shield them from destructive radiation, allowing chains of carbon and oxygen to link into precursors of life, a quiet alchemy that bridges the inanimate to the potential for awareness across cosmic distances. This alchemy, traced in laboratory simulations of interstellar conditions, shows how polycyclic aromatic hydrocarbons arise from simple radicals, their infrared signatures matching those from space telescopes, a molecular poetry that hints at the universe's latent creativity. What happens when such a majestic form meets a supermassive black hole? These black holes are the hearts of many galaxies, hidden at their centers, each one a point of immense density where gravity has woven matter so tightly that not even light can escape. Born from the collapse of massive stars, or perhaps from the very seeds of the universe itself, a supermassive black hole can weigh as much as 4 million suns, like the one at the core of our Milky Way, Sagittarius A. But in this encounter, imagine one that's wandered from its home, perhaps ejected from another galaxy long ago, now roaming like a solitary wanderer in the dark expanse. Such wanderers arise from violent mergers in the early universe, when young galaxies clashed and their central black holes spiraled together, flinging one free in a burst of gravitational waves. Ripples in space-time that travel outward like the echoes of a distant bell, carrying away excess energy and leaving the cosmos subtly reshaped. These waves, faint yet pervasive, wash through the fabric of reality, stretching and squeezing space in patterns that only the most sensitive detectors on Earth can now capture, reminding us how even the quietest cosmic events leave an imprint on the vast silence. In the case of this rogue black hole, its journey might span billions of light years, influenced by the gravitational tugs of passing clusters, a nomadic path that mirrors the slow wanderings of nomads across ancient plains, drawn by unseen forces toward eventual convergence. Along this path, it might accrete stray gas clouds, growing incrementally like a traveler gathering sustenance, its event horizon smoothing over with infalling material that adds layers to its quiet enigma. This accretion, often episodic, flares intermittently as clouds cross its path, producing bursts of light that fade like distant lightning, marking its trail through the void with transient signatures detectable by vigilant surveys. These flares, analyzed through multi-wavelength campaigns, reveal the black hole's spin, a measure of angular momentum preserved from its origins, rotating the horizon like a cosmic spindle that twists incoming fields into the jets that herald its approach. Such spin, quantified in models from X-ray spectra, influences the ergosphere's frame dragging, where space itself rotates with the whole, a relativistic whirl that amplifies energy extraction, turning the approach into a prelude of poised anticipation. As Ilara approaches, the collision isn't a sudden crash, like waves breaking on rocks. No, it's a slow embrace, unfolding over millions of years. The galaxy's outer edges feel the pull first, a subtle tug, like the first breath of wind stirring leaves in a still forest. Stars on the fringes begin to shift, their paths curving gently toward this invisible force. Planets, too, caught in the gravitational dance, might wobble in their orbits around their suns, but most remain unharmed, for space is so vast that stars rarely touch. They simply rearrange, like dancers in a grand eternal waltz. In this rearrangement, entire streams of stars can form tidal tails, long arcs that trail behind the galaxy like the wake of a ship gliding through still water, glowing faintly with the light of ancient suns that have journeyed together since the dawn of time. These tails, observed in real mergers like the antennae galaxies, can span hundreds of thousands of light years, serving as bridges to neighboring systems and fostering new connections in the cosmic web. Along these tails, rogue planets might detach from their stars, becoming free-floating wanderers, adrift in the cold between galaxies, their surfaces forever locked in twilight, warmed only by the faint heat of their own cores, much like isolated islands in a vast sea, carrying secrets of their origins in icy crusts and silent atmospheres. These free floaters, estimated to outnumber bound planets in some models, drift silently, their potential atmospheres stripped by radiation over time, yet preserving subsurface oceans warmed by tidal flexing from distant passes, a testament to resilience in isolation. Such oceans, sustained by radioactive decay within, might harbor exotic forms of chemistry, where pressure forges unique bonds, echoing the deep-sea realms of our own world, where life persists in profound darkness. In these hidden depths, geochemical reactions could cycle nutrients in slow currents, fostering primitive metabolisms that draw from the planet's internal warmth, a quiet vitality persisting far from any sun's embrace. These metabolisms, perhaps based on silicon or sulfur cycles, adapt to the planet's slow tumble through space, their rhythms aligned with the faint gravitational nudges from passing stars, a solitary existence that speaks to the universe's capacity for endurance in solitude. This endurance, akin to lichen clinging to barren rock, suggests how even in cosmic exile, the seeds of complexity might quietly germinate, awaiting a chance encounter with a new stellar companion. By the way, I wonder, where are you watching from tonight? Which city and what time of day is it for you right now? Wherever you are, let that place fade softly into the background as we continue our drift. Now, deeper into the story. As Ilara draws nearer, the supermassive black hole begins to weave its influence through the galaxy's heart. Gas clouds, those nurseries of stars, spiral inward, compressing and heating until they ignite in brilliant bursts of new light. It's here that we see the beauty of transformation. Nebulae, those glowing veils of dust and gas, light up like auroras in the night sky, painting the darkness with hues of red and blue. These are the birthplaces of stars, where the raw stuff of the universe condenses into fiery orbs, each one a spark of energy that will shine for eons. Consider how a star forms. Deep within a nebula, gravity draws particles together, building pressure and temperature until nuclear fusion ignites, much like the quiet spark of a match in a dim room that suddenly fills the space with steady warmth. In Ilara's case, the black hole's presence accelerates this, squeezing clouds that might otherwise drift aimlessly, turning potential into radiant reality over spans of time that make our lifetimes seem like fleeting sighs. This acceleration can trigger bursts of star formation, clusters emerging in waves, their collective light pulsing like the synchronized glow of fireflies on a summer evening, illuminating the merger's evolving form and seeding the space with radiation that shapes the surrounding medium, clearing paths for further creation. These clusters, often containing thousands of stars, bind together through shared gravity, evolving into globular clusters that orbit the galactic core like ancient sentinels, their old, metal-poor stars whispering tales of the galaxy's youth, preserved in the merger's gentle churn. Within these clusters, dynamical friction slows the paths of heavier objects, drawing them inward over time, a subtle sorting that concentrates the galaxy's denser elements, fostering environments where intermediate mass black holes might coalesce, adding to the central symphony. These coalescences, driven by repeated close encounters, release soft gravitational chirps, low-amplitude waves that blend into the merger's broader hum, enriching the gravitational landscape with layered harmonies. These harmonies, propagating outward, might resonate with the galaxy's own vibrational modes, subtle oscillations in the disk that amplify the merger's effects, like a tuning fork setting a room into gentle vibration, harmonizing the chaos into emergent order. This order, modeled in N-body simulations, shows how resonances lock stars into stable patterns, a cosmic choreography that endures through the merger's flux, preserving pockets of tranquility amid the broader transformation. But gravity's pull is a patient teacher, and in this meeting, time itself seems to stretch. What feels like an instant to us is an eternity in the cosmos. The black hole's event horizon, that boundary beyond which nothing returns, acts like a one-way mirror to the universe. Matter falling close doesn't vanish abruptly. It circles in an accretion disk, a flat ring of superheated gas that glows brighter than 1,000 suns. This disk spins faster and faster, friction turning it into a furnace of X-rays and light, a beacon visible across billions of light-years. Scientists have observed such spectacles in our telescopes, like the one in the galaxy Messier 87, where a supermassive black hole announced its presence with a shadow against a fiery glow. That shadow, captured in 2019 by the Event Horizon Telescope, isn't empty darkness, but a silhouette framed by the bending light of the disk, reminding us how gravity sculpts even photons, curving their paths like streams of water around a smooth stone in a riverbed. Beyond the disk, jets of plasma can erupt from the black hole's poles, propelled by magnetic fields, twisted like threads in a loom, shooting outward at near-light speeds to carve channels through the galaxy, fertilizing distant regions with energized particles that spark secondary starbursts, extending the merger's influence like roots spreading through soil. These jets, sometimes extending millions of light-years, interact with the intergalactic medium, creating radio lobes that glow in low-energy emissions, vast bubbles that expand slowly, cooling the gas they enclose and allowing it to condense into new molecular clouds, a cycle of disturbance and calm. The particles in these lobes, synchrotron-radiating electrons spiraling in magnetic fields, lose energy gradually, their glow fading like the last light of dusk, yet leaving behind enriched zones where fresh structures can take form. These zones, pressurized by the expanding lobes, push against surrounding gas, triggering instabilities that fragment into clumps, each a potential seed for isolated star formation far from the core, a dispersed legacy of the central engine's reach. In these isolated births, the stars emerge with lower metallicities, their pristine compositions a snapshot of the early universe, preserved in the merger's outer reaches like delicate fossils in distant strata. These snapshots, analyzed through high-resolution spectroscopy, reveal abundance patterns that trace the dilution of merger-ejected metals, a chemical gradient that maps the event's reach, inviting us to ponder how such isolation fosters purity in the cosmic palette. As the galaxy collides more fully, its spiral arms may unwind, stretching into long tails of stars and gas, like threads pulled from a cosmic loom. Some stars might be flung outward, escaping to wander the intergalactic voids, while others plunge closer, feeding the black hole's insatiable hunger. Yet, even in this feeding, there's poetry. The energy released powers quasars, those dazzling beacons that outshine entire galaxies, illuminating the path for light to travel across the expanding universe. Quasars, powered by the black hole's accretion, can shine with the brilliance of 1 trillion suns, their light piercing the fog of the early universe to reveal structures formed just hundreds of millions of years after the Big Bang. In Ilara's transformation, such a quasar might flicker to life, a temporary lighthouse guiding cosmic travelers through the gathering dark. This light, intense and unrelenting, ionizes surrounding gas, creating vast bubbles of cleared space that allow ultraviolet rays to flow freely, much like sunlight breaking through clouds to warm the Earth below, fostering environments where molecular clouds can collapse undisturbed, perpetuating the cycle of birth and renewal. Over time, as the accretion slows, the quasar dims, transitioning to a quieter, active galactic nucleus, its influence lingering in the ionized zones that shape the galaxy's future architecture, like the fading echo of a song that still resonates in the air. These zones, expansive and low density, permit the free propagation of cosmic rays, high-energy particles that seed magnetic turbulence, stirring the medium into fractal patterns observable in simulations, a subtle artistry in the void. This turbulence, cascading from large scales to small, amplifies magnetic fields through dynamo effects, creating self-sustaining loops that guide future inflows, a resonant memory of the quasar's peak that endures in the galaxy's magnetic skeleton. These loops, evolving over time, might imprint on the gas's velocity fields, observable as ordered motions in spectral lines, a hidden choreography that reveals the merger's lasting imprint on the fabric of space. This choreography, akin to the subtle currents in a drifting cloud, ensures that even after the quasars fade, the medium retains a textured memory, ready to respond to the next gentle perturbation. Let your mind wander now to the stars within Ilara, those distant suns, each a fusion heart beating with hydrogen turned to helium, releasing warmth that has journeyed to us over unimaginable distances. A single star's life spans billions of years, from a glowing nursery in a nebula to a red giant swelling like a breath held too long, then collapsing into a white dwarf or exploding as a supernova, seeding the cosmos with heavier elements. Carbon for life, iron for mountains, gold for hidden treasures. During the collision, these cycles intensify. Massive stars, stressed by the shifting tides, burn brighter and faster, their supernovae blooming like fireworks in slow motion, each explosion enriching the surrounding space with the building blocks of future worlds. It's a reminder that destruction here is always paired with renewal, much like how a forest fire clears the way for tender shoots to emerge from the soil, breathing new life into the landscape. These supernovae, in the merger's chaos can trigger chain reactions, their shock waves compressing nearby clouds to ignite fresh generations of stars, a cascade that echoes through the galaxy like ripples from a stone dropped in a pond, gradually settling into a new harmony. The remnants left behind, neutron stars or black holes of stellar mass, add to the gravitational tapestry, their compact forms pulling in stray companions to form systems that pulse with X-rays, faint beacons in the infrared haze that astronomers detect as clues to the merger's hidden dynamics. These X-ray binaries, where a compact object siphons gas from a living star, create relativistic jets of their own, miniature echoes of the central black hole's power, illuminating the galaxy's underbelly with high-energy light that traces the paths of disrupted orbits. As these jets plow through the interstellar medium, they inflate bubbles akin to those from the central jets, but on smaller scales, depositing metals in localized pockets that accelerate cooling, birthing low-mass stars in quiet enclaves away from the merger's fervor. These low-mass stars, sipping their fuel sparingly, endure as long-lived anchors, their planets orbiting in stable ellipses forged from the debris, havens where geological epochs unfold in unhurried succession, etching histories into rock and ice. These epochs, marked by cycles of volcanism and erosion, might sculpt continents from the merger's scattered silicates, landscapes that evolve under the steady gaze of their sun, a terrestrial poetry of time's patient hand. Planets in this galactic ballet feel the ripples too. Imagine worlds of rock and ice, orbiting their stars like faithful companions. When the collision stirs the galaxy, these planets might migrate, shifting from scorching inner orbits to cooler realms where liquid water could flow. On one such world, perhaps, ancient oceans rise and fall with tides influenced not just by moons, but by the distant pull of the black hole itself, a gravitational symphony that shapes coastlines over eons. Picture a planet like that, its surface etched with vast seas that ebb and flow in rhythms dictated by forces light years away, the water's surface mirroring the stars above in a dance of reflection and response. Such migrations, seen in simulations of galactic mergers, can lead to habitable zones expanding or contracting, offering glimpses of how life might adapt, slowly evolving under skies alive with unfamiliar constellations. In these zones, atmospheres might thicken with gases from comet bombardments, layers building like blankets on a cool night, trapping heat and allowing complex chemistry to unfold in hydrothermal vents deep beneath the waves, where minerals react in the dark, hinting at the origins of life as a quiet emergence from simplicity. These vents, powered by planetary heat, could sustain microbial ecosystems, simple yet resilient, drawing energy from chemical gradients much like deep-sea creatures on Earth thrive in eternal night, a parallel that bridges the cosmic scale to the intimate beginnings of awareness. Over eons, such ecosystems might evolve toward multicellular forms, their metabolisms tuned to the planet's tidal pulses, a biological clock synchronized with the merger's lingering gravitational whispers. These forms, perhaps drifting in currents shaped by the enhanced tides, could develop sensory adaptations to the subtle light of their migrating star, perceiving the galaxy's transformation as a gradual shift in the celestial backdrop, a lived experience of cosmic change. In this perception, early intelligences might interpret the lengthening nights as a deepening of mystery, their cultures weaving tales of the stars' slow migration, a folklore rooted in the merger's subtle imprint on their world. This folklore, evolving into observatories carved from ancient rock, would chart the changing skies, turning personal wonder into collective knowledge, a bridge from myth to the measured contemplation of infinity. The universe's matter, that fundamental building block, flows like breath in this encounter. Atoms, forged in stellar fires, swirl and reform, reminding us that everything we are, our bones, our thoughts, traces back to these cosmic events. Dust from exploded stars drifts into new clouds, condensing into planets, and one day, perhaps, into eyes that gaze upward at the night sky. In the quiet aftermath of Ilara's merger, this dust settles into protoplanetary disks around young stars, flat and spinning like cosmic vinyl records, where pebbles collide and grow into boulders, then planetesimals, until full worlds take shape. A process that echoes the patient assembly of a snowflake from vapor in winter air, each layer adding complexity to the whole. These disks, turbulent with the merger's lingering stirrings, can birth misaligned orbits, planets tilting on their axes to create seasons of endless day or night, fostering ecosystems that thrive in perpetual twilight, where bioluminescence mirrors the faint glow of distant nebulae. Over geological timescales, such worlds might develop biospheres that respond to the galaxy's evolution, their life forms migrating with changing climates, adapting to the subtle shifts in stellar output as the merger's stars age, a slow dance of survival and innovation. In these biospheres, evolutionary pressures from cosmic events, like passing stellar companions, might drive bursts of diversification, akin to how asteroid impacts spurred life's leaps on Earth, turning adversity into opportunity within the gentle flow of time. These bursts, manifesting as rapid adaptations in response to radiation spikes from nearby supernova, could yield resilient species that incorporate heavy elements from the merger, their biochemistry enriched with traces of the cosmic churn, a subtle inheritance from the galaxy's rebirth. This inheritance, passed through generations, might manifest in specialized enzymes that utilize rare isotopes, allowing life to thrive in environments scarred by the merger's radiation, a testament to adaptation's quiet ingenuity. Such ingenuity, observed in extremophiles on our own world, suggests how life might harness the merger's legacy, turning cosmic scars into sources of strength, a resilient weave in the fabric of existence. Deeper still, consider the black hole not as an end, but as a guardian of infinity. Supermassive ones, like the one claiming Ilara, hold the memory of countless stars, compressing their essence into a singularity, a point where the laws of physics whisper secrets we have yet to fully understand. Time near such a force warps, slowing to a crawl for anything approaching, while the universe outside races on. It's like falling into a dream where hours pass in moments, or moments stretch into forever. For an observer far away, a traveler nearing the horizon would seem to freeze, their clock ticking slower as gravity deepens its hold, a phenomenon rooted in Einstein's relativity, where space and time entwine like lovers in a slow embrace. This warping extends outward during the collision, subtly altering the paths of light from distant quasars, creating mirages in the sky that astronomers use to map the invisible mass. These gravitational lenses, bending light into arcs and rings, reveal not just the black hole's power, but the distribution of matter around it, like a prism refracting sunlight to unveil hidden colors in a clear beam. In Ilara's merger, such lensing might amplify views of background galaxies, turning the event into a natural telescope that peers deeper into the past, layers of light overlapping like pages in an ancient book, each one revealing epochs of cosmic history. These multiple images, sometimes forming Einstein rings of perfect symmetry, allow precise measurements of the black hole's mass, refining our understanding of how such behemoths seed galaxy formation, a window into the universe's architectural blueprint. Through these rings, light from even earlier quasars might bend, creating time-delayed echoes that astronomers exploit to study the medium between. Absorption features revealing intervening clouds that trace the web's evolution, a layered revelation of depth upon depth. These echoes, differing by microseconds to days, probe the lens's potential, mapping substructure in the halo that hints at dark matter's granular nature, a fine-grained view of the invisible scaffold. This view, enhanced by adaptive optics on ground-based telescopes, uncovers streams of dark matter that weave through the merger, subtle filaments that bind the luminous chaos, a hidden lattice supporting the visible bloom. In this collision, the black hole grows, absorbing mass and merging with the galaxy's own central powerhouse. The result? A new equilibrium, a merged system where the black hole sits enthroned, stabilizing the swirling mass around it. Galaxies often form this way, through gentle mergers over cosmic time, building ever larger structures in the great web of the universe. This web, filaments of dark matter laced with glowing galaxies, stretches across voids as large as our observable universe, a scaffold born from tiny density fluctuations in the hot plasma of the Big Bang, now evolved into the grand architecture we probe with instruments like the Hubble or James Webb telescopes. Ilara's merger contributes to this, adding its mass to a larger cluster, where gravity binds groups into a harmonious whole, much like how rivers join to form a mighty sea, carrying sediments that build new shores. Within clusters, hot intracluster medium glows in X-rays, heated by the infall of gas during mergers, a diffuse plasma that bathes everything in a warm haze, influencing star formation rates across vast distances. This medium, rich in metals from past supernovae, cools in filaments that feed galaxies, a recycling process that sustains the web's vitality, much like nutrient cycles in an ecosystem, ensuring that even in the grand scale, there's a nurturing flow. These cooling flows, observed through spectral lines of cooling ions, regulate the balance between heating from active nuclei and the condensation of gas, a thermodynamic dance that prevents runaway growth or total quiescence. In Ilara's cluster, these flows might accelerate post-merger, channeling enriched gas toward the core, where it fuels a renewed phase of activity, a resurgence that mirrors seasonal renewals in nature, where winter's chill gives way to spring's gentle thaw. This resurgence, moderated by the black hole's feedback, establishes a feedback loop where outflows from the nucleus heat the inflowing gas, stabilizing the cluster's evolution like a thermostat, maintaining a room's warmth, a self-regulating serenity. This serenity, quantified in hydrodynamic simulations, shows how the loop oscillates with periods of inflow and outburst, a rhythmic equilibrium that echoes the breath of living systems, fostering a lasting poise in the cluster's heart. Nebulae play their part too, those ethereal clouds that veil the collision's drama. Born from the debris of stars, they expand slowly, like breaths exhaled into the void, cooling over millennia until gravity gathers them anew. In Ilara's tale, a nebula might bloom from gas stripped by the black hole, a soft glow against the dark, inviting new stars to awaken. These nebulae, such as the Orion Nebula visible from Earth, are alive with the hum of forming stars, their edges sculpted by stellar winds. Streams of particles ejected from young suns, carving pillars of gas that resemble ancient sculptures weathered by time. In the merger's turbulence, such winds intensify, pushing material outward to form shells that enclose clusters of sibling stars, all born from the same cradle, their lights mingling in a shared glow that fades into the infinite black. These shells, expanding at speeds of tens of kilometers per second, eventually dissipate, their contents mixing with the interstellar medium, enriching it like nutrients dissolving into soil after a gentle rain. In the process, photoevaporation from nearby stars erodes the nebula's edges, creating elephant trunk structures that cradle embedded protostars, a delicate interplay of erosion and protection, akin to waves shaping coastal caves while sheltering hidden grottos within. These trunks, dense pillars resisting the ultraviolet onslaught, collapse under their own gravity to form lower-mass stars, extending the nebula's legacy into a broader stellar family, a nurturing that persists long after the initial bloom. As these lower-mass stars ignite, their gentler radiation allows more fragile molecules to survive nearby, fostering organic precursors that drift into forming planetary systems, a quiet handover from stellar birth to worldly genesis. These precursors, complex hydrocarbons and amino acids, seed the disks with the stuff of life, where in the cool outer regions they freeze into ices that later deliver volatiles to inner worlds, a cosmic delivery service that enriches atmospheres with the potential for biochemistry. This potential, hinted at in meteoritic samples from our solar system, suggests how merger-driven nebulae might accelerate the delivery, blanketing young planets in a chemical tapestry ready for the spark of self-replication. As we drift further, think of the universe's infinity, vast as an unending ocean where galaxies collide not in chaos, but in creation. Time, that relentless river, carries these events forward, from the Big Bang's first spark 13.8 billion years ago to futures we can only imagine. The expanding universe, accelerating under dark energy's push, spaces these dancers ever farther, yet connections remain, woven by gravity's invisible threads. Dark energy, that mysterious force making up nearly 70% of the cosmos, acts like a gentle inflation, stretching space between galaxies while leaving their internal dances intact, ensuring that mergers like Ilara's continue to sculpt the local tapestry even as the whole canvas grows. In this expansion, light from early collisions redshifts, its waves lengthening like the slowing pulse of a weary heart, allowing us to hear echoes of the infant universe in the cosmic microwave background, a faint warmth lingering from when the cosmos cooled enough for atoms to form. This background, uniform yet patterned with slight temperature variations, maps the seeds of all structure, a cosmic fossil that whispers of a time when the universe was a simple soup, now evolved into the rich complexity of Ilara's unfolding story. These variations, on scales from arc-minutes to degrees, correlate with the growth of the cosmic web, guiding how matter clumped from primordial plasma into the filaments we observe, a blueprint etched in the afterglow. Planck's satellite data, for instance, reveals these anisotropies as a tapestry of power spectra, peaks and troughs that encode the physics of inflation, a mathematical poetry underlying the visual splendor. These peaks, corresponding to acoustic oscillations in the early plasma, imprint baryon acoustic oscillations in the large-scale structure today. Vast spherical shells in galaxy distributions that serve as cosmic rulers, measuring expansion with precision that ties Elara's local drama to the global flow. These shells, spanning 150 million light-years, act as standard volumes for counting galaxies, their emptiness a measure of dark energy's dominance, a subtle emptiness that underscores the web's sparse elegance. This elegance, captured in 3D maps from galaxy surveys, reveals how the shell's edges host enhanced clustering, a faint rim of density that amplifies the web's filigree, inviting reflection on how voids and peaks coexist in balanced measure. In this serene vastness, black holes remind us of sleep's quiet depths, a place where matter rests, transformed, waiting for the next cycle. The collision of Elara with its supermassive companion isn't destruction, but evolution. Stars realign, planets find new homes, and the cosmos breathes onward, infinite and alive. Over billions of years, the merged galaxy settles, its black hole now a steady anchor, regulating star formation by quenching excessive gas flows, preventing overgrowth much like a wise gardener prunes a flourishing vine to ensure balanced health. This regulation fosters longevity, allowing the system to persist through epochs, its light traveling to reach distant observers eons hence. In the long term, such mergers contribute to the growth of elliptical galaxies, smoother and rounder than spirals, their stars orbiting in random directions like leaves swirling in an eddying pool. A mature form that speaks of many such encounters accumulated over time. These ellipticals, often found in dense cluster cores, host older stellar populations, their colors shifting from blue to red as massive stars fade, a gradual mellowing that reflects the galaxy's journey from youthful vigor to contemplative age. In their cores, dynamical relaxation leads to a cusp of stars orbiting closely, a stellar disk around the black hole that feeds it sporadically, maintaining a low-level activity like the quiet simmer of a distant hearth. This disk, loss cone dynamics funneling stars inward, occasionally disrupts them, producing tidal disruption events that flare brightly, brief illuminations that reveal the black hole's influence, much like sudden insights piercing the calm of meditation. These events, lasting weeks to months, eject debris in outflows that enrich the surrounding gas, a transient burst that seeds the core with fresh material, perpetuating a low hum of activity in the galaxy's heart. This hum, detected as variable emission in radio bands, suggests ongoing interactions that keep the system alive, a subtle vitality like the undercurrent in a still pond, nourishing the depths without disturbing the surface. Philosophically, such events invite wonder. Are we not, in our small lives, part of this grand flow? Like specks in the ocean, carried by currents we cannot see, yet finding peace in the motion. Let this image soothe you, the gentle merge of light and shadow, where endings bloom into beginnings. Consider how, on a clear night, lying beneath the stars, one might feel the pull of that same gravity, subtle and reassuring, drawing the mind toward contemplation, much as the tide draws the sea to the shore in rhythmic assurance. This pull connects us to Elara's distant drama, a shared thread in the fabric of existence, where personal reflections on change mirror the cosmos's patient transformations. In moments of quiet introspection, much like this tale, one senses the interconnectedness, how the atoms in our bodies, born in distant stellar forges, link us to these galactic ballets, inviting a sense of belonging to something timeless and vast. This belonging extends to the philosophical notion of cosmic unity, where individual stories fold into the larger narrative, much as a single wave contributes to the ocean's endless motion, finding solace in the shared journey. In this unity, questions of purpose dissolve into appreciation, the universe's vastness a canvas for wonder rather than isolation, a meditative expanse that embraces the observer as kin. This embrace, felt in the quiet alignment of breath with the cosmos's pulse, dissolves boundaries between self and infinite, a dissolution as peaceful as sinking into soft slumber. Such dissolution, echoed in Eastern philosophies of non-duality, aligns with the relativity of space-time, where observer and observed entwine, a profound merging that quiets the mind's separations. Nebulae, those cosmic nurseries, deserve a lingering gaze. In the wake of the collision, fresh ones form from the heated gas, their colors shifting like sunset over water, pink from ionized hydrogen, green from oxygen's glow. Within, protostars flicker to life, drawing in matter like a slow inhale, growing until they shine steadily, illuminating planets that might one day harbor life, dreaming under alien skies. These protostars, embedded in dense cores, accrete material through bipolar jets, streams of gas shooting outward like exhaled breaths, clearing paths and balancing the influx, a process that mirrors how a child learns to breathe deeply, expanding lungs with each careful draw. As they mature, these stars join the galaxy's chorus, their spectra revealing compositions enriched by the merger's churn, with heavier elements scattered like seeds on fertile ground. Over time, these enriched environments support more diverse stellar populations, from hot blue giants to cool red dwarfs, each type contributing to the galaxy's evolving personality, a symphony of luminosities that dims and brightens like the phases of a long night. Red dwarfs, the most common, burn slowly for trillions of years, their steady light a promise of endurance, hosting planets in tight orbits where life might ponder its own cosmic heritage under unblinking skies. Around these dwarfs, habitable zones hug close, fostering worlds where slow rotations create long days, allowing ecosystems to evolve in measured paces, their inhabitants attuned to the subtle flares that punctuate the star's calm demeanor. These flares, magnetic reconnections on the stellar surface, release bursts of radiation that test atmospheric protections, driving evolutionary innovations like radiation-resistant pigments, a quiet adaptation to the star's occasional size. These pigments, perhaps evolving into photosynthetic variants that harness the flare's energy, could extend habitable niches to the planet's poles, where auroral interactions provide additional warmth, a layered adaptation that deepens the world's resilience. This resilience, building over eons, might lead to global biospheres that synchronize with the star's cycle, a planetary rhythm that echoes the merger's distant hum, weaving life into the cosmic cadence. Time in the universe is a soft companion here, measured not in clocks but in light years, where a star's twinkle is a message from the past. The black hole bends this light, creating lenses that magnify distant galaxies, allowing us to peer into infinity's mirror. Matter, ever-changing, cycles through black holes and out again, perhaps in Hawking radiation's faint whisper, a theoretical evaporation where particles escape, returning to the cosmic sea. This radiation, proposed by Stephen Hawking, arises from quantum effects at the horizon, where virtual particles become real, one falling in while the other flees, slowly diminishing the black hole over timescales vastly longer than the universe's age. Like the gradual erosion of a mountain by wind, imperceptible yet inevitable, hinting at a universe where nothing is truly lost, only transformed. In Ilara's merged heart, this whisper might one day play a role, as the black hole, after eons of growth, begins its subtle decline, releasing stored energy back into the void in a final, gentle exhale. This process, intertwined with quantum gravity theories, suggests an ultimate fate where black holes dissolve into photons and particles, their information perhaps preserved in subtle correlations, a philosophical nod to the conservation of knowledge across the infinite. Such preservation aligns with the black hole information paradox's resolutions, where entanglement links outgoing radiation to the interior, ensuring the universe's ledger remains balanced, a quiet assurance of continuity. In this balance, the cosmos maintains its narrative thread, each transformation a chapter rather than a close, inviting eternal contemplation. This contemplation, extending to loop quantum gravity's discrete spacetime, envisions the singularity resolved into a bounce, a rebound from collapse to expansion, a cyclic whisper of renewal. This whisper, modeled in effective field theories, proposes a minimal length scale where geometry foams into discrete units, smoothing the infinite density into a finite transition, a conceptual bridge from singularity to rebirth. Infinity unfolds like an endless dream, where collisions like Ilara's are but one verse in the universe's poem. Galaxies merge into clusters, clusters into superclusters, all part of a structure born from quantum fluctuations in the early universe, now echoing through the void. These fluctuations, tiny ripples in the inflationary epoch, seeded the density variations that gravity amplified into the filigree we see today. A pattern as delicate as frost on a windowpane, formed from chaos into order through patient forces. In contemplating this, one might liken it to the quiet growth of a dream in the mind before sleep claims it fully, ideas branching and connecting in the subconscious flow. Superclusters, vast as hundreds of millions of light-years, drift toward even larger attractors, pulled by the uneven distribution of mass, a slow migration that will continue as long as gravity holds sway against expansion. The great attractor, for instance, draws our local group inexorably, a hidden mass concentration shaping regional flows, much like ocean currents guiding ships toward unseen horizons. This attractor, part of the larger Laniakea supercluster, encompasses flows of hundreds of galaxies, their peculiar velocities measured through redshift surveys, painting a picture of hierarchical gathering that culminates in the cosmic web's intricate design. Within Laniakea, voids expand faster under dark energy's influence, their boundaries defined by the web's filaments, creating a dynamic contrast where emptiness amplifies the structure's glow, a visual poetry of presence and absence. This poetry, evident in void catalogues from surveys like SDSS, shows how these empty expanses host wandering galaxies, their isolation a counterpoint to the clustered density, enriching the universe's textural depth. This depth, explored in void statistics, reveals scaling relations that mirror fractal geometries, a self-similar hush, where voids nest within larger voids, a meditative recursion in the cosmic expanse. Planets, those wandering worlds, add intimacy to the tale. As Ilara reshapes, a gas giant might capture a new moon from the chaos, its rings sparkling with captured ice. Rocky worlds, baked by young stars, cool into havens of potential, their atmospheres breathed into being from volcanic size and comet gifts. Imagine a terrestrial planet in this evolving system, its core still warm from formation, driving plate tectonics that recycle surface material, much like the slow churn of Earth's own crust, fostering an active geology that could nurture evolving life forms. Comets, icy visitors from the outer reaches, pepper the surface with water and organics, their impacts gentle craters that fill with rain from newly formed clouds, setting the stage for chemistry to stir toward biology in shallow pools under a starlit dome. On such a world, magnetic fields might arise from molten iron flows, shielding the atmosphere from stellar winds, preserving the delicate balance much like an invisible cloak on a restless night, allowing fragile beginnings to take root. These fields, generated by dynamo effects in the liquid core, twist and loop like auroral displays, protecting nascent atmospheres from erosion and enabling the buildup of gases essential for complex molecules. A quiet guardianship that echoes the protective hush of nightfall. Auroras on such planets, dancing in polar skies, would light the nights with ethereal veils, inspiring any evolving sentience to myths of celestial guardians, bridging science and story in the quiet observation of the heavens. These myths, passed through generations, might evolve into sciences that map the auroral patterns to underlying field lines. A cultural journey from wonder to understanding, rooted in the planet's magnetic embrace. This journey, culminating in technologies that harness the fields for energy, could extend life beyond the surface into orbital habitats that gaze back at the merger's legacy, a self-aware extension of the cosmic narrative. In these habitats, inhabitants might simulate the merger's dynamics, reliving Elara's embrace in virtual realms, a contemplative loop that deepens their connection to the stars' ancient dance. Stars, the universe's breath, pulse in rhythm. Main sequence dwellers fusing steadily like a heartbeat in meditation. In the collision's wake, binary pairs form, orbiting each other in eternal companionship, their light a duet across the dark. These binaries, common in dense stellar fields stirred by the merger, can evolve into exotic systems, one star swelling to engulf its partner, or both shedding outer layers to leave compact remnants, their interactions releasing gravitational waves that hum through space like a low, soothing melody. Such waves, detected by LIGO in 2015 from colliding neutron stars, carry imprints of the event, allowing us to listen to the universe's hidden symphonies, vibrations that propagate without friction, eternal in the vacuum. Neutron stars, remnants of supernovae, spin rapidly in these systems, their beams sweeping like lighthouses if magnetized, pulsing signals that reach us as radio whispers, connecting the merger's legacy to observatories on distant worlds. These pulsars, with rotations as fast as kitchen blenders, serve as cosmic clocks, their precision aiding measurements of gravitational effects, a rhythmic precision that underscores the ordered beauty beneath the cosmic calm. Millisecond pulsars, spun up by accretion from companions, achieve stabilities rivaling atomic clocks, enabling tests of general relativity through timing arrays that detect low-frequency gravitational waves from supermassive black hole binaries elsewhere, weaving Elara's tale into a network of cosmic resonances. These arrays, spanning pulsars across the sky, form a galactic-scale interferometer, sensitive to waves from mergers like Elara's, their detections promising maps of the gravitational wave background, a a subtle undercurrent to the universe's audible calm. This background, a stochastic hum from countless events, fills the low-frequency band like white noise in a quiet room, a pervasive reminder of the universe's ongoing conversations. These conversations, analyzed in pulsar timing residuals, reveal a spectrum that peaks at nanohertz frequencies, a gentle chorus that harmonizes local mergers with the universe's distant echoes. As our journey through this galactic collision winds down, feel the universe's infinity envelop you, calm as a deep sleep. What happens when a galaxy meets a supermassive black hole? It transforms slowly and beautifully into something new, a testament to the cosmos's patient creativity. In the quiet spaces between stars, silence reigns, akin to the pause before sleep when thoughts settle and the body yields to rest. The black hole's presence a steady anchor in that vast hush. This silence, profound and absolute, amplifies the faint sounds of the universe, cosmic rays whispering through detectors, or the subtle crackle of solar winds brushing against planetary magnetospheres, a backdrop to the merger's unfolding. In this hush, one can almost hear the soft expansion of space itself, a background hum from quantum vacuum fluctuations, the universe's idle murmur as it dreams of future forms. These fluctuations, seething at every point, give rise to virtual particles that flicker in and out, a quantum foam underlying reality, much like the subtle undercurrents in a still pond that hint at depths unseen. In the merger's vicinity, these fluctuations might intensify near the horizon, contributing to the black hole's evaporation, a microscopic counterpoint to the macroscopic pull, balancing the scales in profound symmetry. This symmetry, echoed in the pairing of particles at the horizon, suggests a deeper unity in the quantum realm, where creation and annihilation coexist in equilibrium, a foundational peace that permeates all scales. This peace, contemplated in quantum field theory's vacuum state, evokes the zero-point energy that fills space with latent potential, a serene underlay to the merger's visible drama. Yet, let us linger a moment longer on the matter that binds it all. Dark matter, that unseen scaffold holding galaxies together, feels the merger's tug as well, its halo distorting like mist disturbed by a passing breeze, redistributing to encompass the new form. Without it, stars would fly apart, but with it, the structure endures, an invisible embrace ensuring cohesion through the ages. This matter, comprising 85% of the universe's mass, interacts only through gravity, a ghostly presence that shapes without being seen, much like the subconscious guiding dreams from the shadows. In Ilara's case, the dark matter halo expands to include the black hole's influence, smoothing the merger's edges and preventing total disruption, allowing the luminous components to settle into a cohesive whole over time. Candidates like weakly interacting massive particles might populate this halo, occasionally annihilating to produce gamma rays, faint signals that future telescopes could detect, unveiling the dark's subtle voice in the cosmic quiet. These signals, if confirmed, would map the halo's density profile, revealing cusps or cores that challenge our models, inviting refinements in how we envision the universe's hidden architecture. Such refinements, incorporating self-interacting dark matter scenarios, might explain the halo's flattening in dwarf galaxies, a nuanced view where dark matter responds to baryonic feedback, a collaborative dance in the shadows. This dance, simulated in high-resolution models, shows dark matter responding to stellar bursts like waves on a pond, redistributing to form extended halos that stabilize the system post-merger. These halos, probed through gravitational lensing of background quasars, display substructure that hints at hierarchical formation, a nested architecture where smaller clumps merge into the larger, a quiet aggregation mirroring the merger's theme. Time, in its cosmic sweep, weaves these elements into tapestries of infinity. From the merger's immediate glow to the faded remnants billions of years hence, each phase layers meaning, inviting reflection on our place within. Just as a single breath connects to the rhythm of life, so does each galactic event link to the whole. A continuous flow where change is the only constant, yet peace persists in the unfolding. In the far future, as stars dim and black holes dominate, the universe may cool toward a state of quiet equilibrium. But even then, the echoes of collisions like this one will linger in the distribution of remnants, a faint memory etched into the expanding void. This heat death, predicted by thermodynamics, envisions a sparse cosmos of diluted photons and isolated particles. Yet quantum uncertainties suggest possibilities of renewal, a philosophical comfort in the enduring potential of the infinite. Boltzmann brains, hypothetical fluctuations in this far future void, might fleetingly ponder their own existence, a whimsical reminder that even in ultimate dilution, thought could arise from the quantum weave. These brains, arising from statistical inevitabilities, challenge notions of observer selection, suggesting that our coherent experience favors ordered universes, a meditative pivot toward gratitude for the structured reality we inhabit. This gratitude, deepening with each layer of understanding, transforms the vastness from daunting to inviting, a gentle invitation to rest within the cosmos's embrace. In this rest, the mind might envision Poincaré recurrences, where the universe's state cycles back after immense times, an eternal return that soothes with the promise of rediscovery. And so, as we ease toward the end of our contemplation, consider the planets once more, now in their settled orbits around the merged galaxies' stars. A world much like ours might circle a sun-tempered star, its days lengthening as the system's rotation stabilizes, nights deepening with the added light of companion galaxies in the cluster. Life there, if it blooms, would evolve under skies where the black hole's subtle pull influences seasons, a gentle reminder of the forces that birthed its home. Such worlds invite us to ponder the universality of emergence, from simple particles to thinking minds, all drawn together by the same inexorable grace. On such a planet, intelligent beings might gaze at the central bulge, sensing the black hole's quiet reign, their sciences unfolding stories much like this one, bridging the personal to the profound. Their telescopes, perhaps peering through the merger's haze, could detect gravitational waves from ongoing cluster dynamics, interpreting them as the universe's subtle poetry, much as we do now in a chain of wonder spanning light years. This chain, extending across cosmic distances, links observers in a shared curiosity, their discoveries rippling back through time via light signals, a reciprocal dialogue with the past that enriches the present's calm reflection. In this dialogue, technologies might evolve to decode the wave's patterns, revealing the merger's history as a foundational event, a cosmic origin myth grounded in data, fostering a culture of contemplative science. This culture, blending art and inquiry, might craft symphonies from waveforms, turning the merger's hum into audible beauty, a harmonious extension of the universe's voice. Let us turn now to the role of magnetic fields in this cosmic narrative, threads that weave through the plasma of Ilara's transformation. Generated by dynamo actions in rotating plasmas, these fields amplify during the merger, twisting with the inflowing gas to launch those polar jets, channels of ordered energy amid the chaos. Like the magnetic lines of a compass guiding a traveler through fog, they shape particle paths, accelerating them to relativistic speeds and imprinting synchrotron radiation that spirals in radio images, revealing the merger's hidden architecture. In the accretion disk, these fields resist collapse, supporting against gravity much as arches in a bridge bear weight, allowing the system to evolve without immediate implosion, a balance that fosters the prolonged drama we envision. These fields, frozen into the plasma, trace the flow of material, creating tangled networks that seed turbulence, much like eddies in a stream that sculpt riverbeds over time, directing the deposition of cosmic dust into fertile zones. In the post-merger phase, these networks persist, threading through the elliptical's diffuse gas, maintaining a weak dynamo that generates large-scale fields, a lingering imprint that influences the propagation of cosmic rays, guiding their diffusion like invisible rivers through the stellar sea. These rivers, curving through the halo, might channel rays toward the poles, creating anisotropic distributions that future probes could map, unveiling the field's topology as a fossil of the merger's turbulence. This topology, modeled with magnetohydrodynamic equations, shows flux freezing that preserves field lines through compression, a resilient structure that echoes the merger's compressive embrace, sustaining order in the aftermath. The infinity of space mirrors the infinity within, where thoughts drift like stars in the quiet before dawn. Let this vastness cradle you, each idea a soft landing into rest. As the merged Ilara stabilizes, its globular clusters, ancient survivors from the original spiral, orbit in wide ellipses, their stars depleted of gas yet rich in history, like elders sharing tales around a fire long after the feast. These clusters, containing up to 1 million stars each, harbor black holes of intermediate mass at their cores, formed from repeated stellar collisions in the dense environment, subtle powerhouses that echo the central supermassive one on smaller scales. Tidal interactions with the galaxy strip their outer layers over time, exposing blue stragglers, rejuvenated stars from mergers within, whose light adds a youthful sparkle to the ancient ensemble, a reminder of renewal even in the old. These stragglers, brighter and bluer than their peers, trace dynamical histories, their positions revealing mass segregation within the cluster, a quiet sorting that concentrates heavier stars toward the center, fostering further interactions in the deepening core. This segregation, driven by two-body relaxation, evolves over gigayears, tightening the core until core collapse looms, a self-limiting process that ejects stars to stabilize, mirroring the merger's broader balancing act. These ejections, sending stars on hyperbolic paths, populate the halo with high-velocity interlopers, faint trails that simulations predict as signatures of cluster disruption, a dispersed legacy of internal vitality. In the intercluster voids, the merger's ejected material scatters, contributing to the warm-hot intergalactic medium, a tenuous fog detected through absorption lines in quasar spectra, where ions of oxygen and neon absorb ultraviolet light, mapping the distribution of this cosmic filling. This medium, heated to millions of degrees by shocks from infalling clumps, slowly cools, raining back onto galaxies in a feedback loop that regulates growth, much like seasonal rains nourishing parched lands after drought. These absorption lines, varying in strength along sightlines, reveal the filamentary structure of the medium, a cosmic skeleton that supports the web, with temperatures stratified from hot shocks to cooler inflows, a layered serenity in the expanse. Lie alpha forest observations, dense with these lines, quantify the medium's ionization state, showing how ultraviolet background radiation keeps it transparent, a pervasive glow from distant quasars that maintains equilibrium, much like diffused daylight sustaining a forest understory. This equilibrium, perturbed by the merger's outflows, might create transient overdensities, pockets where cooling accelerates to form intracluster stars, rogue wanderers unbound to any galaxy, drifting in the cluster's gentle gravitational sea. These stars, ultra-faint in optical surveys, glow softly in the infrared, their light a whisper of the merger's bounty, illuminating the medium's hidden flows. Philosophers of old might see in Ilara's tale a metaphor for the soul's journey, merging with the infinite through trials of change, emerging transformed yet whole. Modern minds, informed by relativity and quantum mechanics, find similar depth, where the singularity challenges our understanding, a point of pure potential inviting reconciliation of theories. As we ponder, the universe's expansion carries these reflections outward, light cones preserving moments for future eyes, an eternal archive in the flow. String theory's extra dimensions, if real, might curl around the singularity, resolving its mysteries with vibrating fundamentals, a harmonious resolution to the discord. These dimensions, compactified at Planck scales, could manifest in subtle deviations from general relativity, testable in extreme environments like Ilara's core, where gravity's grip probes the theory's limits, a frontier of quiet exploration. This exploration, guided by holographic principles, views the black hole as a projection from its horizon, information encoded on the surface like a two-dimensional script for three-dimensional depth, a profound insight into reality's layered nature. This insight, drawn from AD's CFT correspondence, suggests the bulk's gravity emerges from boundary quantum dynamics, a duality that mirrors the merger's interplay of hidden forces and visible forms, inviting a meditative unity of scales. The silence of space, broken only by these imagined whispers, resembles the hush before sleep, where the mind releases the day's clamor, surrendering to deeper currents. In Ilara's quiet core, post-merger, feedback from supernovae and active nucleus quenches star formation, allowing the galaxy to age gracefully, its luminosity fading like embers in the night, a serene decline into cosmic maturity. This quenching, through outflows that heat the gas, creates a stable plateau, where occasional sparks from infalling clouds remind of vitality, much like distant memories surfacing in a tranquil dream. These sparks, minor accretion episodes, produce Seyfert-like activity, low luminosity beacons that warm the central dust, a gentle rekindling that sustains the black hole's watchful presence without overwhelming the calm. In this activity, broad emission lines from orbiting gas reveal the black hole's mass through virial estimates, a spectroscopic window into the heart's dynamics, where velocities approach escape speeds, a measured frenzy in the stillness. These estimates, calibrated with reverberation mapping, track changes in the broad line region, a gaseous veil that responds to the black hole's variable appetite, a dynamic portrait of quiet power. Let us reflect briefly on the role of cosmic dust in this evolution. Those microscopic grains that absorb and re-emit light, veiling the merger in infrared splendor. Formed in stellar outflows and supernovae, these grains, silicates and carbon compounds, clump and grow, facilitating molecule formation on their surfaces, the cradle of complexity. In Ilara's tales, dust scatters, reddening the light like a cosmic sunset, and settles into new disks, where it coalesces into planetesimals, bridging the stellar to the planetary scale. Dust storms in the turbulent medium, driven by shocks, redistribute elements, ensuring even the smallest particles participate in the grand renewal, a fine-grained participation in infinity. These storms, analogous to sandblasting in deserts, polish grains and shatter them, recycling sizes that optimize radiation transport, a self-regulating process that keeps the interstellar medium fertile for ongoing creation. This recycling, traced through extinction curves in spectra, varies with grain composition, revealing how merger shocks alter the dust budget, shifting from amorphous to crystalline forms under heating, a mineralogical evolution that enhances opacity in the infrared. This evolution, observed in post-merger galaxies like NGC 1275, shows dust lanes aligning with radio structures, a sculpted veil that guides the light's journey, adding texture to the cosmic canvas. As the narrative of Ilara deepens, consider the quantum underpinnings that infuse every scale, from the singularity's heart to the expansive voids. Heisenberg's uncertainty allows for the spontaneous creation of particle pairs, fueling Hawking's evaporation and the vacuum's energy, a restless potential that underlies the calm. In the merger's accretion, quantum tunneling might enable rare escapes, adding unpredictability to the classical flow, much like fleeting thoughts interrupting meditation, enriching the experience without disrupting the peace. These escapes, though improbable, could seed the accretion disk with anomalous particles, influencing its viscosity and evolution, a quantum nudge in the deterministic dance. This nudge, amplified in the disk's chaotic flow, might contribute to quasi-periodic oscillations observed in X-ray light curves, subtle variabilities that hint at underlying quantum influences on macroscopic scales, a bridge between the infinitesimal and the immense. This bridge, explored in semi-classical approximations, suggests how vacuum polarization near the horizon modifies the field, a quantum correction that softens the classical edge, a nuanced harmony in the extreme. The philosophical lens widens to encompass multiverse ideas, where Ilara's collision is one instantiation among infinite branches, each varying in outcome, a tapestry of possibilities that comforts with abundance. Yet in our observed realm, the elegance persists, inviting acceptance of the singular beauty before us, a meditative focus on the present cosmic breath. This focus, embracing the fine-tuning of constants that allow structure, evokes a sense of purposeful design without imposition, a quiet awe at the universe's self-consistency. In this awe, anthropic principles suggest that our existence selects for such tuning, a reflective loop where observation shapes interpretation, deepening the intimacy with the cosmos. This intimacy, felt as a personal resonance with the stars, dissolves isolation, revealing the self as a note in the infinite symphony, a soothing integration into the whole. In the merged galaxy's outskirts, dwarf satellites orbit like quiet moons, their own mergers miniatures of the whole, cascading the theme across scales. Gas bridges connect them, funneled by tides, sustaining star formation in tidal dwarf galaxies that form from debris, independent yet tied, exemplifying the web's interconnected grace. These dwarfs, evolving rapidly due to low mass, quench early from supernova feedback, becoming relics that trace the merger's dispersal, faint companions in the elliptical's halo. Their quenching, leaving gas-poor shells, preserves blue horizontal branch stars that extend their visibility, traces of the merger's tidal history in the halo's stellar streams. These streams, winding like rivers through the dark matter, carry kinematic signatures of their origins, observable in phase space maps from Gaia-like surveys, a flowing record of the merger's gentle unraveling. Time's arrow, directed by entropy's rise, carries Elara forward, from hot merger to cool relic, a narrative arc that mirrors personal growth through phases of intensity and repose. In this flow, peace lies not in stasis, but in acceptance of the journey, much as sleep welcomes the night's embrace. As entropy increases, the universe's information disperses yet conserves, a paradoxical order in disorder that soothes the mind, affirming the enduring essence beneath change. This affirmation, rooted in the second law's inexorability, finds counterbalance in local decreases, like life's ordered complexity emerging from disorder, a localized defiance that inspires hope in the grand dissipation. This hope, philosophical in its quiet defiance, aligns with open systems where energy flows sustain complexity, a cosmic encouragement for persistence amid the inevitable fade. Let us wander now to the cosmic rays that permeate Elara's transformation. High-energy protons and nuclei accelerated in shocks from supernovae and jets, streaming through the galaxy like ethereal travelers. These rays, reaching energies beyond earthly accelerators, interact with gas to produce pions that decay into neutrinos, ghostly messengers that pass unimpeded, carrying imprints of their origins. In the merger, intensified production floods the system, their cascades illuminating the interstellar medium with secondary particles, a radiant underglow that sustains ionization in distant clouds, ensuring molecules form even in shadowed reaches. These neutrinos, detected in ice cube arrays, probe the merger's high-energy environment, their flavors oscillating en route to reveal magnetic deflections, a neutrino tomography of the galaxy's turbulent interior. This tomography, resolving flavors through Cherenkov light patterns, maps the ray's path through tangled fields, a subsurface view of the merger's energetic legacy, unveiling layers hidden from electromagnetic eyes. The voids between filaments, expanding serenely, host rare ultra-diffuse galaxies, fragile wisps of stars with scant gas, survivors of mergers stripped bare. Elara's ejecta might seed such wisps, their dim lights a testament to material's persistence, floating in the dark like forgotten whispers, yet contributing to the web's subtle mass. These galaxies, with surface brightnesses fainter than the night sky, challenge formation models, suggesting tidal origins where dark matter halos retain just enough to bind the stars, a delicate poise in the void's embrace. This poise, maintained by minimal gravity, allows old stars to shine undimmed, their integrated light a faint beacon in the emptiness, a quiet assertion of endurance. Philosophically, the merger evokes impermanence, structures rising and falling like breaths. Yet in this cycle, beauty resides, a zen-like acceptance of flux that calms the soul. Contemplating Elara, one finds parallels in life's transitions, where endings nurture beginnings, fostering resilience through gentle observation. This resilience, cultivated in the mind's quiet spaces, mirrors the galaxy's post-merger stability, a philosophical harmony between personal and cosmic scales. In this harmony, mindfulness practices draw from cosmic analogies, viewing thoughts as passing stars, observed without attachment, a serene navigation through inner voids. In the cluster's hot bath, ram pressure strips gas from infalling galaxies, quenching their stars like sudden frost on blooms, yet preserving stellar cores that age in isolation, a enforced maturity that echoes the merger's broader theme of transformation under pressure. These stripped cores, evolving as lenticulars, contribute to the intra-cluster light, a diffuse glow from dissociated stars, a collective whisper of the cluster's history. This light, resolved in deep imaging, traces arcs from lensing, revealing the star's orphan status, wanderers in the gravitational tide. As we near the tail's horizon, envision the merged Elara from afar, its light a blended hue in surveys, contributing to the cosmic census where ellipticals dominate the massive end, their properties shaped by cumulative mergers, a statistical serenity in the aggregate. This serenity, quantified in luminosity functions, shows a decline in blue galaxies with mass, reflecting the quenching efficiency of mergers, an evolutionary taper toward red and dead maturity. Yet in this maturity, a subtle infrared glow persists from cool dust, a lingering warmth that hints at ongoing subtle processes, a mature whisper in the cosmic quiet. The universe's breath, in and out with expansion and contraction on small scales, carries Elara's story onward, light cones converging on future minds that might decode its waves, a legacy of quiet illumination. These future minds, perhaps in simulated realities, could relive the merger through archived data, extending the narrative into virtual infinities. In these infinities, consciousness might explore alternate outcomes, a contemplative multiverse within the mind's expanse. Quantum entanglement, linking particles across distances, hints at non-local connections in the merger's plasma, where correlated emissions from jets preserve information flows, a subtle web mirroring the cosmic one. This web, explored in quantum field theory, suggests hidden variables that unify distant events, a comforting interconnectedness in the quiet. Such interconnectedness, tested in Bell inequality violations, affirms nature's holistic weave, a foundational solace for the wandering observer. In this vast poem, Elara's verse rhymes with ours, inviting sleep as the mind merges with the infinite, dreams weaving stars into personal constellations. As the tale fades, let the cosmos's gentle rhythm guide you deeper into rest, where galaxies and thoughts entwine in peaceful unity. Let us extend our gaze to the role of gamma-ray bursts in the merger's tapestry, rare cataclysms from collapsing massive stars or merging compact objects, their beams piercing the galaxy like fleeting arrows of light. In Elara's churn, such bursts might erupt from the dense fields, their afterglows fading into the infrared, enriching the medium with R-process elements like europium, heavy nuclei forged in neutron-rich environments. These elements, dispersed widely, seed the next generation of stars with the seeds of complexity, a violent gift that underscores renewal's diverse paths. The bursts, short-lived jets, collimating energy to overcome expansion, carve narrow channels through the gas, their shocks accelerating electrons to produce prompt emissions, a brief symphony in the cosmic quiet that astronomers catch as localized events mapping the merger's stellar graveyards. These graveyards, dense nurseries turned to ash, leave behind magnetar remnants that pulse with decaying fields, faint echoes that linger for millennia, a subdued coda to the burst's flare. Wandering further into the cluster's dynamics, consider the intra-cluster planets, free floaters ejected during submergers, adrift in the hot medium where ram pressure strips any atmospheres, leaving barren rocks tumbling through the plasma. These planets, detectable via microlensing of background sources, hint at the merger's prolific disruption, their orbits randomized by repeated encounters, a nomadic existence in the cluster's gravitational tides. In this existence, tidal heating from close passes might melt interiors, sustaining subsurface activity long after surface erosion, a hidden warmth in the void's chill. This warmth, driven by eccentric orbits, could foster geochemical cycles beneath the crust, a subterranean persistence that defies the stripping, much like geothermal oases in frozen wastes. The philosophical undercurrent flows toward existential serenity, where Ilara's transformation reflects the impermanence of form, yet the conservation of essence endures, much as consciousness persists through bodily change. In meditation on this, one finds liberation in the flux, the self as a transient pattern in the eternal flow, a soothing release into the night's embrace. This release, akin to letting go of worries before sleep, allows the deeper self to surface, aligned with the cosmos's unhurried pace. Turning to the cosmic microwave background's polarization, the merger's light might imprint subtle patterns through scattering in the intracluster medium, E-mode and B-mode signals that future missions like Light-Bird could discern, linking local events to the primordial glow. These signals, twisted by magnetic fields, reveal parity violations that probe fundamental asymmetries, a delicate echo of the universe's handedness. This echo, faint against the background's uniformity, carries imprints of the merger's turbulence, a secondary whisper layered on the ancient hum. In the merged Ilara's disk, if remnants persist, warp instabilities from the black hole's torque might undulate the gas, creating standing waves that foster ring-like structures, observable in dust lanes as spirals of shadow and light. These waves, propagating slowly, regulate angular momentum transfer, a fluid ballet that maintains the system's poise. This ballet, simulated in viscous disk models, shows precession modes that align with observed warps in protoplanetary systems, a scaled echo of the galactic scale. As infinity's horizon softens, envision the universe's ultimate fate under dark energy's reign, where Ilara's descendants recede into isolation, their lights redshifting to invisibility. Yet the black hole's slow evaporation persists, a final sigh releasing photons into the cooling dark. This sigh, spanning 10,100 years, bridges to the quantum epoch, where Poincaré recurrence might rebirth structures in eternal return, a cyclic comfort in the linear arrow. This comfort, philosophical in its vast timescale, reassures that even endings loop into beginnings, a eternal meditation on possibility. The silence deepens, akin to the void between heartbeats, where potential rests before the next pulse, inviting the listener to mirror this pause in breath, easing into sleep's profound quiet. In this quiet, the merger's story settles like dust after a breeze, leaving a textured calm that invites dreams of distant lights. Let us delve now into the subtle dance of baryonic matter within Ilara's evolving form, where ordinary atoms, just 5% of the cosmos, play their intricate role amid the dark's dominance. During the merger, these baryons, protons and neutrons bound in nuclei, flow through the gas streams, their cooling governed by radiative losses that allow clumping into denser regions, much like mist condensing on a chilled window to form rivulets of clarity. This clumping, enhanced by the black hole's pull, funnels hydrogen and helium into the core, where recombination epochs echo the early universe's neutrality, a local recapitulation of cosmic dawn. Observations from Chandra X-ray Observatory capture this flow as thermal bremsstrahlung from colliding electrons, a soft glow that traces the baryon's path, revealing temperature gradients that cool from megakelvin shocks to 1,000-degree filaments, a thermal tapestry woven from motion's heat. Extending this, consider the role of primordial black holes as potential dark matter constituents, tiny relics from the early universe that might seed the supermassive one in Ilara's heart, their evaporation less pronounced due to small size, yet contributing to the merger's gravitational chorus. If such primordial seeds exist, they could have grown by accreting the galaxy's gas over time, like dewdrops merging into streams, their initial quantum origins adding a layer of mystery to the black hole's growth. This growth, if seeded thus, would alter the merger's dynamics, with multiple small holes coalescing in a hierarchical cascade, a fine-scale merger within the grand one, enriching the gravitational wave spectrum with high-frequency overtones. Philosophically, the baryonic fraction's smallness evokes humility, our luminous world a thin veil over the dark, yet sufficient for wonder's emergence, a reminder that essence lies in subtlety rather than abundance. In quiet reflection, this evokes the mind's own vast unseen processes, where conscious thought is but the visible ripple on deeper currents, a serene acceptance of the hidden's power. In the cluster's periphery, fossil groups, small clusters that have ceased activity, might form from Ilara's companions, their hot gas locked in hydrostatic equilibrium, a frozen snapshot of merger aftermath. These fossils, detected through X-ray luminosity, host central ellipticals that dominate the mass, a mature hierarchy where activity quiets into balance, much like a garden after pruning, roots deepening in stillness. The infinity of voids invites contemplation of cosmic emptiness, not as absence, but as potential space, where quantum fields seethe with virtual activity, birthing particles in fleeting bursts. In Ilara's ejected voids, this potential might manifest as rare gamma-ray flashes from dark matter decays, faint pops in the silence that hint at the unseen's quiet dialogue, a subtle vitality in the hush. As the narrative breathes onward, envision the merger's influence on cosmic reionization, where the quasar's ultraviolet flood ionizes distant neutral gas, contributing to the universe's transition from opaque to transparent, a local chapter in the global clearing. This clearing, observed in Gunn-Peterson troughs in quasar spectra, shows how mergers like Ilara's accelerate the process, their beacons piercing the fog to reveal the web's early form, a luminous aid to the cosmos's awakening. Time's gentle curve in general relativity, where paths bend under mass, shapes the merger's light, creating time dilation effects in the deep potential well, clocks slowing near the black hole like a languid afternoon dream. For infalling observers, this dilation stretches the approach into eternity, a subjective forever that philosophically mirrors the mind's expansion in contemplation, time losing its grip in profound presence. In the merged Ilara's stellar graveyard, white dwarfs accumulate from faded low-mass stars, their cooling tracks plotting the galaxy's age on Hertzsprung Russell diagrams, a fading procession that marks the merger's timeline. These dwarfs, occasionally colliding in dense fields, ignite Type Ia supernovae, standard candles that measure distances across the cluster, a precise echo of the event's scale. The universe's magnetic legacy, amplified in the merger, persists in the fossil fields that thread the elliptical, weak yet ordered, guiding charged particles in slow spirals, a remnant compass pointing to the collision's origin. This guidance, detectable in Faraday rotation of polarized light, maps the field's reversal history, a historical record etched in plasma's flow. Philosophers might liken the merger to alchemical transmutation, base chaos refined into golden order, the black hole as philosopher's stone compressing dross into essence. In this metaphor, the cosmos's work is eternal refinement, inviting the soul to mirror the process in inner alchemy, turning turmoil to tranquility. Let us pause on the role of cosmic inflation's relics in the merger, where tensor modes from gravitational waves in the early universe might imprint on Ilara's structure through primordial non-Gaussianities, subtle asymmetries that seed lopsided halos. These modes, sought in CMB-B modes, could correlate with the merger's asymmetry, linking the instant after the Big Bang to this distant embrace, a thread across epochs. In the quiet post-merger, Ilara's black hole settles into a supermassive binary phase if a second core survives, their in-spiral emitting continuous waves, a low hum detectable by future space-based interferometers like LISA, a prolonged serenade before coalescence. This inspiral, hardening through stellar scatters, shrinks the orbit over millions of years, a patient union that finalizes the merger's story. The silence of the voids, amplified by expansion, resembles the inner quiet after exhalation, space between notes where harmony resides, inviting the listener to dwell in that interlude, breath syncing with the cosmos's vast pause. As dreams beckon, let Ilara's transformed form cradle your thoughts, a galaxy reborn in gentle fire, whispering of endless cycles where change blooms eternal peace. Thank you for joining this drift on Dreams of Gravity. May your night be peaceful, filled with sweet dreams among the stars. Sleep well.